the second part of this lovely experience is you're going to do a simple chromatography experiment. But before we do that, we're going to talk about forensics. And I would like you to tell me what forensics is, if anybody knows. Nikita?
Forensic scientist.
Yes, of course. Okay, so Nikita actually wants to talk about what a forensic scientist is.
There's a scientist that investigates crimes.
Okay, scientist that investigates crime. So now that Nikita has said that, does it trigger your memory on what forensics is? Forensics. Alex?
I don't know a definition, but I know it has to do with fingerprints and stuff like
Absolutely. Have you guys seen any CSI movies? Yes. What's that all about, Natasha?
that. It's like when you have to investigate like a murder or something, and you have to find fingerprints on the murder weapon or something like that, or blood left there.
Do you guys find that interesting?
Yes.
Yeah? It's exciting. Some movies are quite exciting, and there are a series of movies that people your age watch. So basically, chromatography is a lovely, simple experiment that forensic scientists use. And today we're going to quickly look at what a forensic scientist is. We're going to think about various techniques used by a forensic scientist when investigating a crime scene. And we're going to carry out a small experiment. So a forensic scientist, I think you told me already, he basically collects evidence and analyzes evidence from crime scenes. And you mentioned a couple of things that he may do, which was footprints, collecting blood. What else do they do? Fingerprints. Anything else, guys? Think it does?
Maybe the DNA.
Well, if they find some, let's say some form of hair on somebody, then they may analyze that person's hair or whatever else they may find.
I'm also guessing like what happened, like how the person got killed.
Yeah, there is so much. So, for example, they have to find out how a person was killed, if it was a murder crime, or where the intruder came into a house that was burgled, from where. And fingerprints are really interesting one we're going to look at. So a forensic scientist, he may or she may work outdoors or in a lab. And if they work in a lab, they're actually going to be using lots of techniques to analyze the substances brought in by the other forensic scientists which work outdoors. And a range of different roles taken up by forensic scientists, and you guys have said almost everything. You didn't say anything about handwriting, which is actually a big science. And there's another one which is a popular one these days. It's computer analysis. You get a lot of frauds happening on the internet. And data recovery. I mean, I don't know if you guys have ever heard of people taking your data and then asking you for money in return to give it back to you. Yeah, so that happens. So forensic scientists could help there. And just to look at a few things before we carry out our experiments. So what would a fingerprint tell you? Imagine, sorry, not a fingerprint, a footprint. What would a footprint tell you, Alicia?
Like the size of the shoe.
Perfect. The size of the intruder's shoes. You get that?
What type of shoe?
Yeah, whether they were wearing sportswear or just what type of shoes.
Like the route they took.
Absolutely, the route they took. Yep.
Maybe because if he wears shoes, the shoes might have been in the house. And there might be other signs of his house that have been on the shoe, so they might find something.
So maybe you would find some evidence on the shoe from where else that person had been.
Yes, from his house.
Do you know when that's brilliant? Another thing that I found very interesting when I was looking this up, you can see whether someone's limping or not from the footprints. There's a lot of evidence you can collect. So everything, you guys have said everything so far. Running, staggering, the manner they're walking. Right, there was a very high profile case in the 90s, maybe Miss Fotini will remember this, and it was O.J. Simpson. Do you remember the O.J. Simpson case? A little bit. Now, the O.J. Simpson case was a case where it was a very famous multi-millionaire footballer. I don't know if you remember it. And he had committed a crime, and they actually, do you remember how they framed him?
I've heard of something, and I think they gave like money so he can get out. Or...
They did. It was a very high-profile case, and I don't remember the details, but I remember how they framed him, and it was because he wore a specific shoe from a specific brand, and he had a very large 46. So someone can get framed from that. Evidence, how it's collected, guys. How do you think a forensic scientist will collect evidence to take into a lab? Will he just pick it up and put it in his suitcase? That sound?
With gloves and like little bags with a number
Excellent.
of what evidence is.
Gloves. You watch a lot of TV, don't you? Okay, brilliant. And then these are just sort of different things. Metal airtight tins. Why do I want airtight tins? Why don't I want air in the tin? Yes.
Maybe so it can preserve it as perfect.
What do I want to get rid of?
Oxygen?
Like oxygen. What would oxygen do to something?
Maybe it'll not preserve it in the right way.
Yeah, you're right. Nikita?
So no bacteria or any infection would touch the thing.
That's great. So again, you don't want oxygen, so you don't get any oxidation occurring, any changing of any chemicals, or you don't want any germs to enter, because you don't want something to rot. So if somebody does collect items, they can brush surfaces with a small brush. With some sellotape, they can collect anything like fingerprints, for example. Right, and the next thing I want you to look at, right, yeah, there it is. So the next thing, guys, is basically a small clip from a CSI movie, and this talks about how somebody that committed a crime said they were at work, but they weren't, and they forged a date. They wrote the wrong date, and the detectives, the forensic scientists, wanted to find out whether the date was forged. So they took the date written and they looked at the ink, and they wanted to see whether the date, the ink of the date, matched the same ink that the letter he wrote at work did. So there was this guy that committed a crime, and they didn't know whether it was him or not. So he said he was at work, and he said, well, I was at work and I made an order. This is the order I made, and this is the date. And they wanted to see whether the order matched the date. Okay, so let's have a quick look. The volume.
There were two different inks on the work order, which means the date on the work order was compromised. Tom Harper made a service call at the office house, not in December, but 10 months earlier in February.
Brilliant. Did you guys understand that? Mm-hmm. Okay, so what's chromatography? This is where we're going to do our experiment. What's chromatography, guys? Alex?
So there is a chromatography paper, and you can add like the ink, and if there is a match on top, then you know it was the ink used. But if it's not on top, then it doesn't match.
Okay, so chromatography, if you think about the definition or about where the word comes from, what do you think it is? Alicia?
Like colors.
Something to do with colours, right? You guys know Greek, you're really lucky. So you can look at the words and break it up. So it's like something to do with colours. So it's like the study of colours or writing. And chromatography is used a lot in forensics, guys. It's used, for example, in counterfeiting, where some money are made, like you get fake money, and then they can tell that the money's fake by using chromatography. It's also used in DNA analysis, for example. You mentioned DNA analysis, to check whether we have substances in medicines that we don't want, or maybe if somebody, like a sportsman, has taken a drug they shouldn't take. Do you know what that is, guys? Like when some sports people take drugs to make them stronger, and they're not allowed, and they get disqualified. So they can use chromatography to find that out. So it's used vastly. It really is. So we go back to. So it means color writing, guys. So basically, what it's used for, it's really simple. You have this paper, this piece of paper we call a chromatography paper. Like at school, if you did it in school, you would probably use the filter paper. But here we're going to use something better. And you draw a line around 1.5 centimeters from the bottom with a pencil, and then you dot onto that line different things you want to analyze. So for example here, let me just go to the next slide. I can't go to this one. Let's say here, in this case, we want to find out what this mixture is made up of. So you would have like a dot of the mixture you want to analyze, and all these 6 dots that you would have had here would have been substances that you know, and then you would put this paper inside a container with a liquid, and the liquid will be absorbed, and when it's absorbed it would take all these substances with it. So it depends on how far the substance is. So every substance is different. So number 1 is different from number 2. And that's different from number 3, etc. Can you tell me what the mixture is made up of? Alex first.
5.
5, because it's the same level, guys.
Yeah, and 3.
And 3 because it's the same level. So here I can actually identify what my mixture is made up of. Okay, so this is one way we can use chromatography. You can identify what your mixture is made up of. Another way that we can use chromatography is to see what a substance is. So, for example, if I go back here to this, again here you can see it's happening. I can see, for example, this mixture is made up of this and this. This is a mixture, guys. What would you call the red dye? It's a pure substance. It's pure because only one substance is, it's made up of one substance. So, why do you think the substances in the mixture are separated? Can you think about why they're separated? Yes, Nikita?
Because the color was a mixture of 2 colors.
The color was a mixture of 2 colors. So why has one color traveled up further than the other? So remember, this was dipped in a solvent. Yes, Alex?
Solubility depends on how soluble the substance is.
Definitely. So what you have to do with chromatography, this is what you're going to do. You're going to take a chromatography paper. You're going to draw a very thin line with a ruler around 1.5 centimeters. You're going to put a substance here. You're going to put it in a beaker which has some liquid. The liquid will be absorbed, And if your substance is a mixture, you're going to see it being separated. Okay, so I haven't done this slowly because we're running out of time, but let me see. We have let me see about this. So I want to talk about keywords. So this is the chromatography paper. This is the pencil. These are the substances you want to analyze. This here is called a trough or a beaker, and inside there's a solvent, it's liquid. Now I want this solvent to be able to dissolve my mixture. Okay, so if my mixture is not water soluble, will I use water? No. I will use another substance. First case, guys, we're going to talk about before we carry out the experiment is, imagine there was a painting, a very expensive painting that was stolen, and it was replaced by a fake. Just have a, don't know if you can see the writing, but you can tell me, how can I find out whether the painting's a fake or whether it was a very old, expensive painting? What do I do? So imagine I walk into my museum and I see a painting in front of me, and it's not the original, it's a fake. I'm sure it's a fake. How do I find out whether I'm right or wrong? What do I do?
You take it and you put it in a solvent.
I don't take the painting and put it in a solvent. What do I do? Nadas?
I'm guessing the type of paints would be different.
The type of paint, excellent. How are they different?
Because they didn't have as many chemicals and stuff.
Excellent. What did they have in the past? Nikita, sorry, you had the hand up.
I was going to ask.
But what do you guys think they had in the past? Like, let's say hundreds of years ago. What did they use to paint with? Theo?
Natural colors?
Absolutely, natural colours. Natural colours, are they pure substances or mixtures? They're actually pure. Now they paint with mixtures. So what I would do, Miss Tanya, I wouldn't put the whole painting, but what I would do is I would take some of the colour, some of the paint, I would remove it, and I would carry out chromatography on it.
Yeah, but if it was the real one and then you just remove
You wouldn't remove a chunk of it, you would remove a tiny bit. And this is actually quite a good technique. So if you want to buy, let's say you want to buy an expensive painting when you're older, okay, and you want to make sure that it's not a fake, you can ask somebody to do this for you.
What if it's from an older painting, but they mixed the paints while they were painting, and you?
Oh, they never did that. They never used to do that. But again, that's very interesting. So the paints are different to paints of today. So you would see some difference in the chromatography.
Even if it's from a combination of all those pure paints,
you will see today when we look at even like black is made up of one black is different to another black.
Mm-hmm.
So another case, guys, is the Soham case. I don't know, maybe Fadini remembers this. This happened around 2002, where two people went missing, and they were wearing Manchester United football t-shirts. They went missing, and people were looking for them everywhere. Their shirts were found, but the people weren't found. And the police went into, they were looking, they had a suspect, they went into the suspect's house, they found some red fibres of the t-shirt. And they analysed the colour of the red fibres with the colour of the t-shirts, and they found a match. That's how they framed the guy. So again, chromatography was used here. And the final case is your case. So Theo, can you read that for me, please?
Image your teacher.
Imagine.
Oh.
Sorry.
Imagine your teacher received a threatening note. She suspects somebody is in her year 3 class. She asks him to carry out a chromatography experiment using their blank pens. She carries out chromatography on her note and compares her result to the pupils who wrote the notes.
Yeah. So what you're going to do, guys, you're each going to get markers. So one of you wrote a very threatening letter to your teacher. So what you're doing is, so let's see who it is. So I actually took some of the ink found in the threatening letter. Where is it now?
Can you write threatening letters?
You don't write a threatening letter, pretend you did. Where did I put the colour? Right, guys, now you're going to carry out the experiment. So imagine I received a threatening letter and I suspect one of you guys. So I'm asking you to carry out an experiment using your pen. So what you're going to do is you're going to get a chromatography paper, which you all have, and you're going to take a ruler and you're going to draw a nice line with a pencil at around 1.5 centimeters from the bottom. Doesn't have to be precise. Important thing is that it's done with a pencil. This is known as your baseline. Fine, yeah. Fine.
That's good.
Guys, because we're only investigating one colour, one pen, we're not investigating many pens, you can draw with your pencil a lovely little cross in the middle of your line, your base line. Little cross, just in the middle. Let's see, little cross. With your pencil. Listen to instructions. Right, now you can use your pen, your black pen, yeah, which is my evidence, and you're going to jot, you're going to basically just tap, you're not going to scratch off the silica on your chromatography paper, you're going to jot, you're going to just tap, and you should get like a little circle. You should tap with your pen onto your cross. Okay? You've drawn a little line. Do you want another paper, Nikita? Okay. We all ready? Andy, are you ready? You put your chromatography paper inside your beaker. You're going to do it, and in such a fashion that it's going to be as straight as possible. Okay, now, before you actually put your chromatography paper into your beaker, I want you to fill your beaker with acetone. Now that, guys, the acetone is the solvent. It's the liquid. That's going to do a lot of work. I'm not going to go into this in a lot of detail because we want to keep it simple. Most important thing is I want my solvent to be below the baseline. So what's going to happen is my solvent is going to travel up the chromatography paper and it will take the colours with it. So the instructions are to fill your beaker just around 1 centimeter high with acetone. So when you place your chromatography paper, the baseline is above the solvent. This is the acetone. And what I'm going to do, guys, I'm going to do my experiment, because I have taken a sample of ink from my threatening note. I'm going to place my beaker here, and I'm going to wait and see what pattern I'm going to come up with. You can guess exactly what I've got. This is just acetone. When you clean your nails, do you paint your nails? Obviously,
I definitely do.
not everyone does. We just leave it, let it be. Wow. Nadasa's pen has got blue, purple, and yellow. Alicia's has a red line. Alex's looks like it's just pure black, as Andis does, and Nikita's is very interesting indeed. It's quite a bright colour. Right, guys, and I have just realised that. Let's see. Let me just ignore this bit. I've changed my whose looks like this. I did. Because I think my other one had dried out because I did it earlier. I changed it. Who wrote my threatening note? Can you guys gather? Let's see. Shall we remove it? I think that we've seen enough. Can all of you come with your chromatogram? That's what it's called. It's called a chromatogram. Who has written the threatening letter? I think Andy should tell me. I don't think Andy has. His was just plain black. Andy, who wrote my letter? Whose chromatogram does mine match with? Who was the naughty person? Was it you, Nikita?
No, I just wasted
Okay. Who was it, guys?
What does that look like?
It was, yeah, everyone's pointing at you, Nadasa. You were the one who wrote the threatening letter. What did I do?
Well, no, what does this mean? Just lift it off the ground.
So you can see that not all black pens are made of the same colours, and that we've managed to separate the colours found in the black pen. And we found our culprit. Round of applause for Nadasa. She did a very good job.
Mine just decided to fly.